We still have a spot left here at the front. Yes. Hello, everyone. Welcome. If I could get everyone's attention. Thank you. Well, nice to see that everyone showed up here and that you're at the Data and Drinks meetup. Today we have a special speaker. We have Eduardo Bonet from GitLab. And he will be guiding us how we can come from a data stack to a culture for MLOps. So I hope you're all excited and you found a spot to sit. If you're tired or standing, we also have the live stream open at the front of the entrance, but I think we have one talk today. I think it should be doable. Sorry for the inconvenience. We have one toilet today. The other one's broken. I think you saw the signs. You can go to the toilet here or upstairs. Then you get also a nice view of our beautiful Amsterdam office. But I think that's. I hope you found everything. It's kind of self-service here. So you can take a drink out of the fridge. We have soft drinks or beers. And also got a request, if you would like to put your jacket somewhere away, we have a wardrobe at the entrance as well, just behind the tables where you could get the food and stuff. So before we start, I would like to give an introduction to Xomnia. And we host these events also to get your attention, of course, and tell us a bit about us. So I will keep it short. So we are an artificial intelligence company, which means that we do projects with different clients throughout the Netherlands. We have different roles here at the company, and one of them is machine learning engineer. And I think that role really fits fits this talk. We have data engineers, data scientists, and the latest translators and data architects. What we do with MLOps. So this talk is about MLOps. First of all, we build data platforms. So sometimes a client comes to us and they come with us with an analytical question, but they don't have the infrastructure or the technical know-how how to implement this. So we help them building this platform from scratch, thinking along how can we scale this platform, but also how can we do machine learning on this platform. We also start new machine learning projects at different clients throughout the Netherlands. So they come to us with a real concrete question, for example, build us a recommender system, and then we help with that, for example. But we also are at clients to improve their existing data and machine learning stack by being part of their team, for example. So they might already have the capabilities in-house and we support them. So these are some of our clients. We have Hema, Adidas, and for example, myself, I'm working at Albert Heijn as a client at the moment. So for me, I started 3 years ago as a junior data engineer in the traineeship. And the traineeship is also a big part of what we do. We give trainings to juniors and really educate them to become even better engineers. So we do consultancy, also give trainings to externals. We help them with strategies. And now we've grown and are still growing. So this is our team. We had a team outing 2 months ago. And this is also a big part of what we do. We come here every Friday, have a drink, and share knowledge, just like today, but then within our company ourselves as well. So really, we're small, so everyone knows each other. And I really value the personal vibe here as well. So that was it for my part. I just wanted to do a shout out. We are looking for people. That's also one of the reasons why we do this. It's mainly to bring everyone together, but these are some vacancies. So if you know someone who is considering switching jobs or are yourself, please reach out to us. If everyone from Xomnia could raise their hands, then you can see who they are. Okay. And some of us also have the Xomnia sticker on their chest, so you can also recognize them if you want to reach out. Without further ado, I want to introduce our speaker, Eduardo Bonet. Give him a big applause.
Okay, hello everyone. Hello, and thank you for joining. Today we're going to talk about MLOps, but in a different way. We're going to talk about the culture that's behind the well-known almost stack. Quick introduction. My name is Eduardo. I am from Brazil. I share my house with my partner, with my 3-year-old kid, and my 5-year-old golden retriever named Patatia. She's the only one with a Dutch passport, by the way. And I am a staff incubation engineer at GitLab. Incubation engineering meaning I try to find ways to add MLOps features into GitLab. So I've been working for a while on Jupyter Notebook diffs, so you can now code review Jupyter Notebooks. And now I'm working on experiment tracking within GitLab. So you can use MLflow and then connect to GitLab. I am a generalist. I was an Android developer, backend data scientist, machine learning engineer, and some other things. And you can reach out to me at Twitter or LinkedIn. This is where I share updates, what I do in GitLab. Why I'm going to give you this talk today. One, most of the talks that I see, most of the content on MLOps, they talk about solutions. They talk about model registry. They talk about data pipelines. They talk about feature store or whatever, and they don't talk about the problems. They don't see MLOps, especially because a lot of them are given by vendors. So, and they don't talk about the problems of MLOps. And today I'm going to talk about the problems. I want to take a look at MLOps through a different angle. You see, I am not an academic. I am a software engineer first and foremost, that did a little bit of a lot of machine learning meanwhile. So this is where my perspective comes in. This is the perspective that I have. It might be different from depending on our experience, on how you look at, on how you've worked, and it changes from person to person. So this is the overview. There's a lot of words. I will repeat this slide many times throughout the talk. I want to give 4 main messages over here. First, MLOps goes beyond the stack. It starts before the first data is queried, and it's about figuring out what to do to iterate faster on your machine learning features. The second one, the fundamental difference between a classic software and machine learning is that on software, the logic is made explicit through the code. And on machine learning, the logic is implicit on the data and extracted potentially through some code. And this will be the cornerstone of what we'll discuss later on how the problems of machine learning. Second, this is the fire one. From the perspective, it's not that MLOps is a branch of DevOps, it's a superset of DevOps. MLOps has all the problems that DevOps has, but DevOps doesn't have all the problems that MLOps has. So this is the more, and the fourth point, your stack should only be composed of tools that you actually use or that solves your problems. There's no preconceived MLOps stack that is like everybody should use or something. It should solve your problem, and it needs to make you iterate faster. That's the prerequisite for choosing a tool. So, what is DevOps? Let's start. Well, on AWS website, I like this definition. Is the combination of cultural, philosophies, practices, and tools that increase an organization's ability to deliver applications and services at high velocity. So from the first part, we already see that they define cultural, philosophies, practice, and tools. Tools is just one of the 3 main aspects over there. And we can just extend this to MLOps and say it's pretty much the same thing, but instead of just software application services, it's application services that use machine learning. So machine learning is a key component of these new services. And the key word over here is velocity. And velocity means deliver things that matter faster. So it's not just delivering, it's just not putting things out there. It actually has to bring value somehow to the business, to the user, or something. Otherwise, it's just wasted time. And it is shown that to deliver things that matter faster, the better way is to iterate faster. It's not to create a big thing and then deliver, it's to release something that's probably a little bit crappy and then iterate until it gets better and better and better. This is the one of the best ways to get something that do. So what are ways that we can iterate faster? You can do faster deploys. You can automate everything. You can give easier access to the data, improve the pipelines of the data. But is that all? Of course, it's not. Otherwise, my talk will be over here. No. So some ways that you can do this faster. You can choose the right problems to tackle in the first place. You can find a better team setup. So you might not have the better distribution on your team. You might be missing a machine learning engineer. You might be missing a data scientist, or you have too many data scientists. You can improve your communication with stakeholders. You can decrease distance to final users. There are many ways that you can improve velocity that are not related to tech. They are not related to tech, just this tech, and yet they are still making things faster. So this is from the Practical MLOps book. He says, this is from Noah Gift. He says that there's MLOps is for 25% of each of this. 25% DevOps, 25% data, 25% models. So the numbers doesn't really matter over there. It's just that there's a lot more going on here than just the final tools that you see that you see over there. There are a lot of, and often it's a lot better to focus on the cultural part, on how to set up the team, rather than on the tech, on the final, or putting a model registry or something out there. So coming back to the definition that I shared later for what I'm going to talk with MLOps, is that MLOps is the combination of culture, philosophies, practices, and tools that increase an organization's ability to deliver applications and services that use machine learning at high velocity. So you don't need to memorize this. I didn't, and nobody will. It's just that this is how I will define MLOps throughout the talk. So this was the first point that I shared. That it goes beyond the stack. It's about sitting down and figure out how to iterate faster, either through tech. Tech is always, it can be a solution, or through better team topology, or communication with stakeholders, or choosing the right problems, or whatever. And the second point that I'm going to talk about is how MLOps relates to DevOps. You see that on the previous slide, on the Noah Gift slide, he said 25% DevOps, and I'm going to challenge that from very soon. So I want to talk about the difference by talking what is supposed to do. So yeah, we spoke about what is iterate faster, but how? What is the difference between MLOps and DevOps? To do that, first I'm going to talk what is the difference between classic software and software that includes machine learning. So for classic software, you start wanting a behavior. It's either you want to show something to the user, you want to transform, you want to output some data, or you want to do some behavior internally at the system. So you want some behavior. For this, you take some data and you apply some code. That code imbues the logic, right? This is pretty much, well, if you can give me an example, I'll be happy to update this. But for me, this is pretty much all of the software, the summary of software engineering in general. And then machine learning also has this. You have some behavior, you have some logic that takes some data. But the problem is where does this logic come from? This logic comes from a weird data set, a different one. And you have some code that extracts that logic to another piece that will be used with new data that will come later. So this is how I see classic versus machine learning engineering. It's almost as a second order machine learning. You have software engineering that outputs the software engineering block, right? So your code will output the logic, but then it becomes that comes with a lot of problems with it. Does the data that you have really has that logic? Is the code that you write able to extract that logic? Is the logic produced the same as the logic in the first one? When you apply a new data to the logic you produced, does it result on the behavior that you want? How much data do you really need to extract that logic? How do you version the logic that you extracted? It's not so many problems that come with adding machine learning to your stack that it becomes overwhelming, even with the amount of jobs to be done, that you need to care about. And this is why I consider myself, for myself, machine learning as a last resort. When you cannot do, when you exhausted all your possibilities to solve the problem with regular software, then you think about, well, perhaps maybe we can use machine learning over here. No, but so, and this is what it was. This is the second point that I want to share. The fundamental difference between classic software is that on software, the logic is explicit in the code, and machine learning, the logic is implicit in the data and extracted by the code. And this underlies the entire problems that MLOps tries to solve. It tries to tackle this not imbalance, but this difference, this uniqueness. And for me, this is also one of the reasons why code review is not so often so useful on machine learning as it is in classic software, because when you do code review on classic software, you are both reviewing the code and the logic at the same time. But when you review the code for machine learning, you only review the code that extracts the logic, not the logic itself. And this is a very interesting job to be done from MLOps that is not really... There was one paper recently that tackled this, that tried to add the diffs into the for neural networks and some stuff like this. This is a very, very brand new area, and one that makes a lot of that if we are able to achieve this, being able to code to version not the artifact but the logic of the machine learning model, then we will be at another level of machine learning development. And then from this, think about this. This is I'm not going to share everything, but I created a list of jobs to be done. Jobs to be done is a term that a product uses to describe what your tool or what your product needs to solve for the user, what the user wants that your product solves. This is jobs to be done. And I spent a little bit of time looking at the jobs to be done for MLOps. You can check that later. It's on, and it kind of looks like this. There are 38 jobs to be done that I added, and I keep adding every time I think about it. I keep adding. This is on GitLab's handbook, so it's a Git repository. I think anyone can submit a pull request, even a merge request. Sorry, and and yeah, so these are two examples, but when training a model, I want to run part of my code in one or more remote machines so that I can finish training faster. For example, this is a job to be done of MLOps that MLOps needs to solve for the user, or might need to solve for the user. If I will go back once, if you look at the corner right, corner left, this is reference. That is the DevOps lifecycle. It's how we split internally at GitLab the DevOps stages. So you have create, verify. It goes through the whole software development. But what matters is that each one of this has about 18 to 20 jobs to be done. They create each one 18 to 20 or something like that job to be done. And MLOps itself, myself, that I thinking had 36 jobs to be done additionally to all of those that are in DevOps. And that's where these ones come in. The relation between MLOps and DevOps has been discussed quite widely. And this is a personal opinion. This is not a fact. This is not something. I'm happy to be challenged over here. There was a fire over here, but the emoji didn't appear on PDF. I don't know why. Anyways, for me, looking at the problems that need to be solved, MLOps is a superset of DevOps. Everything that you need to solve when you do a system with machine learning, you need the things that solve regular software development. But that's the other side. A lot of the problems that you have with machine learning have already been solved by DevOps companies or by DevOps culture. So a lot of what we do at the beginning of MLOps, we try to reinvent the wheel with a lot of different things. We try to re-implement a lot of different tooling. I'll talk about a little bit later, an example. But now we're starting to realize that we're just reinventing the things. They are already there. Sure, MLOps needs something specific to MLOps, but we can reuse what DevOps has taught us for a long time. And DevOps is a lot more mature than MLOps. So it's duplicated. And this is where my question comes in, because I know this is a little bit of an inflationary statement. If you have any counterexample, I would love to update my slide deck or something. You can tell me later, or on Twitter. I'll probably be running. I have something, but you can tell me on LinkedIn or Twitter later. And this is the third point. MLOps has all the problems DevOps has, but not the opposite. The opposite is not true. And the last point. Sure, I spoke a lot about problems, but where does the stack come in? How do I choose my stack? The stack comes from common problems to be solved. So it's not that some of the tools that you choose are common. It's common to need a model registry. Like it's like you have to version your models, you have to version your metadata. So it's common. Likely everyone will have to use a model registry at some point, or a data pipeline, or a DAG, or something needs. But the thing is, it needs to make your iteration faster. I share an example. So when I was working as a machine learning engineer before I joined my current GitLab, our entire pipeline was running on GitLab. So it was a machine learning that was training on GitLab. And then, okay, we wanted to make something machine learning, and then we chose Kubeflow. And then we migrated to Kubeflow. And it was terrible, because Kubeflow solves a lot of problems we didn't have, and created a lot of problems that we did not have before. So it was unnecessary. It was just unnecessary. And a lot of the tooling we think about, it might be nice to add, it might be fancy, it might be, oh, I want to share my tech stack on Twitter or something, some of those pretty blocks. They will not solve your problem. They will just be adding, sometimes it's worth it to hack on your GitHub actions that you have or something like that, rather than trying to add a full new stack or a full new tooling that nobody else in the companies understand but you. This was the problem we have. So, okay, data scientists ask for a Kubeflow or something, but who's going to maintain that? The data scientists or the platform engineers of the company? If the platforms are maintaining engineers, they're not going to be wanting to learn a full new language to this. Or even the finance department plays a role in this. Finance department hates to have a multitude of small tools to bill every single month or quarter or year. They prefer to have only a single one that they can pay everything. Okay, got done. This is also security. If you have 100 new tools going on or dependencies on your deployment, how do you maintain the security? How can you assure that none of that is leaking, or there wasn't a commit that had added some bad behavior in this? So it's always biased to what you already have to solve the problems. And unless there's something that really solves the problem, choosing a new tool is always a problematic decision. And this is it. What are the problems that you and your org, this is the core of MLOps, is about sitting down and thinking about this phrase. What do you need on your org? What is troubling you on your org? Is it problem with the stakeholders? Is it you can't access the right data, or the data is too stale, or the data is bad, or I don't know? Is it you can't deploy fast? Your deployment is too slow, or it's too buggy, you cannot push, or you don't have a way to, for example, compare two models in a proper way. Which one is it? Which tool will solve? And that's the last point. That was a lot faster than what I was expecting, so I guess it's great. That means I talk fast. Your stack should only be composed of tools that will help you iterate faster. That's the last point that I wanted to share. And did I just finish in 15 minutes? That was it? Sorry. Okay. Your stack should only be composed of tools that will help you iterate faster. That's the fourth point that I wanted to share. So, thank you. And you can reach me out on Eduardo on Twitter or LinkedIn. I post the world update. Everything that I do on GitLab is open. We are open source, and I share updates bi-weekly. Right now, I'm working, as I said, on model registry, and I will be not model registry, sorry, experiment tracking. And I will be looking for. I'm looking for testers for. I think in a month we'll start open test, private tests. And yeah, that's it. Yeah, so I think we have quite a few time for questions now.
If you could repeat the question.
Yeah. Questions?
Do you think we still should do code reviews as a data scientist?
The question is, do you think we still should do code review as a data scientist? And absolutely yes. This is why I implemented Jupyter Notebook Divs, because I wanted to have code review because there are two types of works in data science. One, the code review for the machine learning code, that is also needs to be reviewed because that can also be buggy. There is logic in that code. It's just not the final logic, and that if you get the middle logic wrong, it might lead to the wrong logic in the end. So you still need to do code review. But the second part, which I think it's even more important, is when you have, for example, a report to your to the stakeholders or to business, because then that is the final artifact. If you fail something on that code, if there's a minus or a plus or something, or you fail how to fetch the data, it can completely alter the decision that the report will lead to make. So on there is even more important than the machine learning code for me.
Hi, thanks for the presentation. So, still trying to think how to formulate the question. But it really resonated how you define the difference between software and software development and ML development. Now, if you're a big company, you have very defined teams. You have a team that does, data science, and a team that does software, and probably, you have enough people to do both. If you are, let's say, in smaller companies where maybe your product, totally hypothetical situation here, and your product, let's say, is based on ML, but you need the whole, all the data pipelines, all the software that goes around the machine learning model. So actually software becomes almost bigger than the actual model itself. And you are, let's say, a smaller amount of people. How do you then, do you have any tips to, let's say, create a team that can support both MLOps, so like how to create machine learning and maintain them and follow certain processes, but then at the same time support the software part? Because let's say if you have all the data pipelines until you started learning the model, those really follow more the software development process than the MLOps.
My advice is always try to keep as much as possible to your org capabilities. So if you have more people on the DevOps, try to even hack your way using that. If that doesn't work, try managed, paying a managed, so that you don't have to pay you don't have to manage yourselves the whole stack. It's a little bit harder to get the approval and everything, and if not, go for the one that is most common, because that's the one that's going to be has the most most popular. Will probably have the more how can I say, support online, or easier to ask questions online or something. But that is a problem that will appear all the time, and sometimes it's when you do oh, I didn't repeat the question right. The question is sorry, everyone that's online. Yeah, the question was, when you're a startup, when you're a small company, when you don't have the money or you're the crowd for full teams of both DevOps platform and MLOps platform, how do you handle those? And that was the question. And yeah, that was my answer. Oh, did I get it correct?
Yeah.
Okay.
Yeah, from the 4 points that you shared,
Mhm.
What do you see is the one that companies lack the most?
I think the second one is more of a thought piece rather than a point. The question is, out of the 4 points that I shared, out of these 4 points, what is the one that the companies most lack? It's the last one. I think it's your stack should only be composed of tools that will help you iterate faster. Often we choose tools not having the full understanding of what that's going to impact us on our development, on how do we get, and if it doesn't help you iterate faster, then it means nothing adding that tool. Even if it makes sometimes we add a tool that makes some part of the thing better and makes the other a lot worse.
So DevOps kind of was made to break the silos between dev and ops. And your fourth point is about choosing your own tools and iterating faster, probably isolating your ML people from the larger organization. We're speaking about large companies with cloud centers of excellence and stuff like that. So isn't it controversial?
The question was rather the fourth point isolates the MLOps, folks, and I would say it's the opposite, because the talk was about getting together MLOps folks to the existing DevOps platforms or tools that already exist in the company on the orgs. So instead of asking the platform engineers to do something special for them, the data scientists should try as much, or machine learning engineers should try as much as possible to use what's already in there with the company. So it follows the DevOps of, okay, let's put everything together instead of splitting up and just add when it's absolutely necessary.
Thank you, first of all, for the talk. It's very nice. I have a question. Here we're in a very clean situation. There are users. Let's assume they're already working in the company. Stack is already defined. Company pays money, and yeah, it's just extra effort for these tools, but you're kind of forced to use it. So yeah, what would be your advice in this case? What can you do?
You hit me with the tough questions. Okay, the question is, if you join a company that already has a tool and you believe that it's a little bit overkill or something and you want to go simpler, test what's simpler, because often we don't know, we join a company and we don't know the context of why that tool is in there. Perhaps in the past something was learned that tool made it effect, or perhaps it was just on that example that I gave on to Kubeflow, we went back to regular pipelines just because it was a lot simpler and was adding too much time for maintenance. Yeah. Then it deals with the problem of vendor lock-in and everything, which is another different situation.
My point was that you not always can influence this.
Yeah.
And you probably don't want to go in prediction to the company.
Yes.
But it's still not convenient, and then you in this situation of conflict.
The comment is that there's a conflict between the tooling of what the data scientist wants, and it's kind of like how to balance that. And it's about what is convenient for everyone, right? It's not only for the data scientist. It might be a better tooling for the data scientist, but then it requires more maintenance. In this case, it's the opposite. It requires more maintenance, and it's more of a problem. And then it's a cultural thing that needs to be dealt with the company, with the org. It needs to be raised. It needs to be have a counter, a business case, or whatever. But yeah.
So as an engineer, I think we know that there is many tools on the market today. And my question is, do you have kind of a methodology or a resource to be able to pick up the right bouquet of tools for given common problem that you might encounter?
I try to be. The question is, do you have a rule of thumb on how to pick up the best tool? Like I said before on the other question over there, trying to go with the one that gives the least maintenance. It could be one. I don't have an answer for that. This is like one of the biggest challenges for everyone, I guess. I'm not trying to pretend that I know a lot over here. But going for one with low maintenance, going for simple ones, not that adds too many features into the bucket. Sometimes it's useful, and going for the one that people have familiarity with as well. If there's more data scientists that have familiarity with one tool, but you believe another tool is better, just go for the one that more people have familiarity with.
You don't have a resource that map it a bit into category.
This is what I want to do with the job. Like the question, we don't have a resource with mapping the mapping what problems each tool. This is what I was trying to do. I want to do with jobs to be done. Now that the list of things that need the problems to be solved, we can map those problems to existing vendors out there. But this is a job to be done.
From your personal experience, when do you really stop hacking the tool you're using and start looking for new ones?
The question is, when do you stop hacking and when you start adding new tools? When there's no answer to that. It's when it becomes too cumbersome to maintain the hacks. Because when you do a hack, it requires maintenance either way. So it's a short-term thing. It's a tech debt that you're adding to the system, and you need to at some point pay off either with refactoring or with adding a new tool to handle that tech debt. There's absolutely no answer to that. It will be highly dependent on the company and what kind of hack did you do in the first place. Yeah.
Does unit testing exist in MLOps, or the logic is embedded and you just cross your fingers and hope that everything works?
It can. The question is, does unit test exist in MLOps? It does. It's part of it. It's not common to have it. You can have unit test for the code that generates the logic, but you can also have unit tests trying to. You have you have like end-to-end thing. End-to-end is a lot harder, but unit tests will be on the code, on the ML code itself, but not on the logic that is generated. The logic that is generated is a little bit harder to test the code. You could try with toy. You have a toy data set, and then it generates a logic, but then yeah, it is a unit test somehow. But it does. You can do that. Yeah.
The Jupyter notebook div that you created.
Uh-huh.
Can you tell a little bit more about the project? How long took it? Which language?
Okay, so the question is the Jupyter Notebook diff that I created. How long did it took? And just a little bit more. So it is part of GitLab. When you push a code to GitLab, a Jupyter Notebook, it creates. What I do over there, I transform the Jupyter Notebook into a Jupyter Notebook is a JSON file. That's what it is. It's a JSON file in a really annoying way, but it is. And being a JSON file, it's really cool that you can transform this into a Markdown file. So what I do, I transform this into a Markdown file, and I strip out a lot of stuff that I myself deemed unnecessary, like execution or something. So it's very opinionated on what it appears over there. And then you diff the output Markdown files. So you have the diff on the code, and you have the diff on the output. So if there's an image that is different from one another, you can see the before and after. If there's a difference on tables, you can see it because it was transformed in text. Code base, GitLab is Ruby, so I coded everything in Ruby. I started with Go to be faster, but then since everything is Ruby, I coded in Ruby.
Yeah, another question, if I can. So what defines the most challenging in MLOps? What is something that you cannot solve easily?
What is the most challenging thing in DevOps, in MLOps, is finding the right problems to solve. Finding when to go for ML and when not to go for ML. What's the cutoff point that you stop doing heuristics and then you move on to actually using ML? That is quite complicated because that requires you understanding if you have the data, if your methodology works with that, and that's a little bit more complicated. Deploying, those are difficult. In some situations, a lot difficult. if you have too large of a data set, if you have too large of a model, then it becomes a problem. But for you to reach that point, probably already know that you were working on that thing. But finding what to do with ML, that's for me the most complicated part. Yeah. I did it. Okay, I did it.
So you talked about all the tools, and you're saying MLOps goes beyond the stack, and
Mhm.
you're of course a thought leader at GitLab. So are there any features that we can expect that GitLab will be implementing, or will it
Yeah.
be going? Yeah.
So the question is: there any features that you can expect from GitLab on MLOps? Yes, there are. We are foremost in DevOps, and we are working now on. We have a team. I work as incubation, and I do more of scouting of what might be interesting, and then we have an MLOps team as well, working on actual features or working in a different way. On my side, as I mentioned, you can expect model experiment tracking. So when you're running your tests, your hyperparameter tuning, or just your regular pipelines, you can expect that the GitLab will support the MLflow client. So use MLflow client, instead of sending data to MLflow, you send data to GitLab. You can use your own installation, for example. And from the other team, you can expect a model registry. This is already being worked on. They are both creating features with ML and creating features for ML users. So they just released recommendations for reviewers, and they're working on. I have a colleague that is also an incubation engineer, hacking, trying to find a way to add code completion, smart code completion into GitLab, how to do that, how to add large models into that. And model registry is also the one that's going to be appearing soon.
So you're going to get called out if you write bad code from GitLab.
Oh, yeah. Yeah, I'm going to be called out, yes.
Is this model registry will be again based on the MLflow model registry, or will it be something?
No, the model registry is based on GitLab's package registries. So what we already have, what users already know, that's going to be based over there. And the ML experiment tracking is itself a new thing within GitLab. It's not a release of MLflow. We have coded the experiment tracking. It's just that interfaces that answers to the API that MLflow does. The same API.
What are your thoughts on reproducibility in machine learning?
The question is, what are the thoughts on reproducibility in machine learning? There are three things necessary for reproducibility in machine learning. It's the same data, it's the same code, it's the same hyperparameters. Those are the three building blocks to be able to reproduce. And of course, you need to reproduce, and this is why I'm working on model experiment tracking, because then you can track the metadata. But yes, you should always try for reproducibility. Especially if you put your models are going into production and there's a bug and you cannot understand why, or if there is a litigation happening, it might be necessary for you to be able to explain or show what that model is doing. So in a different setup, so it's absolutely necessary.
Frameworks like the trading process is fundamentally not reproducible unless you train on one CPU.
Yeah.
It's never a should or should not. It's depending on the situation. The question is, TensorFlow is fundamentally not reproducible. Bear with me. By the end of the day, I might be able to remember to do this. The question is, TensorFlow is fundamentally not reproducible. Should you care? Should you still use it? And my answer is, there's no should or should not. This was the whole thing. If it fits your flow, if reproducibility is not that impactful into your flow, then it's okay. But it will depend on the use case. It will not depend on some dude talking in front of all of you for some reason. It will depend on the users and your business and things like that.
Yeah, another question. So you said that the main difference of MLOps from software engineering that we cannot explain the structure. But for this, we have this new trend with explainable AI, right? So, what do you think about this? If we stick ourselves only to explainable AI, can we just reduce all of these difficulties and go back to first order?
You don't, like, the question is, if you use explainable AI, does it go back? Does it make it as easy off as software, regular software? No. Because there's still, okay, how do you fetch the data? Where the data comes from? It does make it easier than non-explainable AI, because then you know what the logic is. Then you understand, and that makes it a lot easier. Like, some of the problems you don't need to solve anymore. They're not problems for you anymore, but some of the others are. So being able to extract the data, provide the data during running time, provide the logic during running time, all of these are still there, but some of the problems don't appear anymore. Cool?
There were a lot of questions. So give it a applause.
Thank you.
Thank you so much, Eduardo, for your nice talk. It was a bit shorter, but I think we filled it up with questions, so thank you so much for that as well. Yeah, so that was it for today for the talks. We already planned a new one for next month again, so feel free to come by as well. This is about the energy sector, about how the energy transition is fueled by machine learning. So we have two interesting speakers, one from Enexis, a grid provider, and one from SimPower, which is a startup in the field. So hope to see you there, and enjoy your night. We're still open with drinks and stuff, so stick around. See you then.